Okay, we will start with today's session then. Others will join meanwhile. So let me just tell you what we are going to see in today's session. We will see or understand one of the important concept or terms, and that is signal layer and control layer. What is meant by signal layer and control layer? That is especially applicable in pneumatic systems, and you must understand difference between these two. So you can see that in the circuit diagram. In last 3-4 lectures, we have been continuously looking to some concepts, as well as every time we are talking about the applications of those concepts like different gates, OR gate, AND gate. And then we were discussing all that by using a circuit diagram. So this is a typical circuit diagram. I hope now you are very much familiar with this circuit diagram, pneumatic circuit diagram rather. Now in this circuit diagram, as I told you earlier, this is the control wall. This is roller lever type of control wall. This is again a roller lever type of control wall. This is push button type of control wall. Push button 3x2 control wall. Roller lever 3x2 control wall. Roller lever 3x2 control wall. This is main direction control wall, which is 5x2 direction control wall. Now let us see what is meant by signal air and control air. Signal air actuates final control wall, and control air flows to the cylinder through the final control wall for forward and backward movement of the piston rod. So while explaining this circuit diagram, you must be aware about a very important concept, and that is signal air and control air. What is signal air? Signal air is that which actuates control wall. This is the control wall. This is the control wall. Okay. This is again a control wall. So this signal coming here, which is actuating this control wall, signal coming here, which is actuating this control wall, this signal, this air is referred as signal air. This air is referred as signal air. Similarly here, this air up to this is referred as signal air. Compressed air will come from the compressor, from primary treatment unit, from secondary treatment unit. That compressed air is called as signal air up to this point. Okay, and what is control air? Control air flows to the cylinder through the final control wall. This is final control wall. We have always referred it in last few lectures as final control wall or main control wall. So control air is that which flows to the cylinder through final control wall. This is called as control air. This is control air. This is not control air. This is signal air. This is also signal air. This is also signal air. So up to final control wall is signal air. From final control wall to cylinder is control air. Up to final control wall it is signal air. From final control wall to cylinder it is control air. I hope this is understood. I hope the concept is understood now. Okay?
Yes, sir.
Right. Let us see different types of walls for sensing the positions. In circuit diagrams, in some applications, we have always seen that there is a roller lever wall here. This is a roller lever wall. This is push button wall. Right. Now, push button wall is not referring to position sensing, but roller lever wall is to be kept here. It should be positioned here. Here also roller lever wall should be positioned. Push button wall is not positioned here. 1.3 is roller lever wall. 1.4 is again roller lever wall. 1.2 is push button wall. 1.2, which is push button wall, is not positioned here. What is difference between push button valve and roller lever valves? Difference is that roller lever valves are placed along the path of movement of piston and piston rod, and then this roller lever valve will be actuated once cylinder, piston and piston rod come to a specific position. For example, this is starting position, this is end position. So when it comes to this position, this roller lever valve will be actuated. When it comes to this position, cylinder, piston and piston rod, then this particular valve will be actuated. So what roller lever valves are doing here? Roller lever valves are sensing the positions of the piston rod. Now what are those positions? Two examples of the positions can be given as start of extension, end of extension. Right? Start of the extension, end of extension. One should sense the position of the piston rod when it ends the extension stroke of the cylinder. So how to know about it? To know or to sense such position, what is done is such lever valves are used, roller lever valves. These roller lever valves are called as the valves used for sensing the positions. Let me clarify over here, or you should understand, push button valve is not used for sensing position. Is that okay? Push button valve is not used for sensing the position. You agree with this or not? Hello?
Yes, sir.
Because if you look to earlier diagram, this has nothing to do with the position of the piston rod. You have to push this button, compressed air supply will start. You have to push the button again, compressed air supply will be blocked. Right? You push it, the supply will be on. You push it again, supply will be off. That is not the case over here. If this valve positioned over here is activated, then extension will start. If this lever valve positioned here along the path of movement of piston and piston rod, this lever valve will be actuated, and accordingly the signal will be given for forward and backward movement of the piston rod. Now for to begin the extension, to end the extension, to begin the retraction, to end the retraction, all these positions will be sensed by these control valves. So how that is done? You can see here. This is a roller lever valve. This is again a roller lever valve. There is cam surface at the end of piston rod. This is the piston, this is piston rod, and this is cam surface at the end of piston rod. So when it comes here, this cam surface touches the roller lever, and therefore it is actuated. This is activated. Now this is activated means what? If we refer this as lower position, this as upper position will be activated. Therefore supply will go from this port to this port. It is connected from this port to this port. Right? Now piston rod will start traveling and will start towards the completion of extension stroke. When extension stroke is completed, there again one more roller lever valve is positioned along the length of path of movement of the piston rod. Now at the end of extension stroke, this roller lever valve will be activated because this cam surface will touch this roller lever now. Now at this point of time, what happens is extension stroke is completed. That is what is sensed. Now in the circuit diagrams also, you should show it very precisely this way. If there are different roller lever valves, which roller lever valve is activated? That is shown with the help of such a symbol. If there are two roller lever valves, which roller lever valve is activated in the circuit diagram that you have presently drawn? It is shown like this. Now let us go back to the circuit diagram. Let's see. Roller lever valve 1.4, roller lever valve 1.3. Out of these two roller lever valves, which one is activated at present? Answer my question. There are two roller lever valves, 1.3 and 1.4. Which one is activated at present? Hello? Hello?
Hello, 1.4.
Correct. 1.4 is activated, 1.3 is deactivated at present. So in the circuit diagram that you have drawn at present, what it suggests is the compressed air supply will come to this port. This once push button is pressed, and then it will go through this port. It will go here. It will activate this side. It will go to the full bore side of the double acting cylinder. So this particular roller lever valve is activated right now. Roller lever valve 1.3 will be activated when extension stroke will be completed and it touches 1.3. So if that position you have shown in the circuit diagram, you should show such a symbol here. That's it. That is again important. You should show with the help of such a symbol to indicate which of the roller lever valve is activated at that instant of time. So as far as this double acting cylinder is concerned, two positions are shown, A0 and A1. A0 position is activated. So this is the roller lever valve corresponding to A0 position, this one. And A1 is at present not activated. It will be activated later on once piston rod will complete its extension stroke. Piston rod ends are provided with cam surface like this for activating position sensing devices. This is position sensing device, this is position sensing device. Now there are two such position sensing devices, or rather roller lever valves are categorized as roller lever valve and another is roller lever valve with idle return. There are two types of roller lever valves. First is roller lever control valve and second is idle return roller lever type of control valve or roller lever type of control valve with idle return. What is that? Let us see. There is a difference the way it is shown symbolically. Here there is one additional lever. Here there is no additional lever. Right? As the name indicates, roller lever will be activated during forward as well as backward strokes. Idle roller lever, in that case, return is idle. So this is roller lever actuator. This is plain 3x2 control valve. So there is nothing new into it. This is spring return. This indicates roller lever kind of control valve. So it is called as roller lever type of 3x2 control valve. Now let's see here. Idle return roller lever type of control valve. Roller lever valve with idle return is actuated when roller lever is transferred by cam of a cylinder in a certain direction. This one. After release of the roller lever, the valve is returned to its initial position by a return spring. After release of roller lever means, what is meant by release of roller lever? It means cam surface is not in contact with the roller lever. When cam surface is touching the roller lever, it will be activated. And when it releases it, then it will start the stroke, next stroke. After release of the roller lever, valve is returned to its initial position by return spring. When transferred in the reverse direction, roller lever has idle return and valve is not actuated. So during return, valve is not actuated. And roller lever kind of valve is actuated during forward as well as during return. What I mean is there is a roller lever valve here. To start the extension, it is activated. Now it comes to the end of extension. To start the return, again this is activated. But if here is roller lever type of valve and here is idle return type of valve, then this roller lever valve will be activated during start of extension, but during start of retraction or return stroke, this is not actuated or activated. The return stroke will be due to spring action. After release of roller lever, valve is returned to its initial position by return spring. When traversed in the reverse direction, roller lever has an idle return and valve is not actuated. I hope this is Understood. Let me know if there are any questions. If not, we'll then go ahead. Hope this is understood. We will further see actual circuit diagrams, and then maybe we will take a quick feedback as usual. Let us see two circuit diagrams for pneumatic circuit diagrams, which demonstrates application of roller lever valve. This is something which we have seen earlier. In the beginning, I had talked about this circuit diagram. So how it works? Let's see. Every time for every circuit diagram, I have tried to write flow of the signal from 0th phase to 100% completion phase. So that way it will be easier for you to understand how it works. So how it works, let's see. Flow of the signal 1.2. So it starts with 1.2. Push button valve or detent valve. It is called as detent valve also. So press it, supply will start. Press it again, supply will be off. So press it, then it will go to. Now you should say in your description that signal air will go from push button valve 1.2 to roller lever valve 1.4. Signal air, not control air. Then in the control valve, roller lever type of control valve 1.4, it activate the left position. Therefore signal air will go to main direction control valve, and this signal here, which is nothing but pilot signal, this pilot signal activates left position of main direction control valve or final direction control valve 1.1. Therefore signal air, now it is control air. Up to this it is signal air, which has actuated the left position of the main or final direction control valve. Now control air from here will be connected to this line, and it will go and enter in the full bore side of the double acting cylinder, which causes the extension stroke to start for the double acting cylinder. And then from the right side, that is rod side of the double acting cylinder, the supply will come back to the exhaust. Or rather what will happen is it will go ahead and it will activate. Extension stroke has started in the first phase. Now extension stroke will begin. The cylinder rod with cam surface now will activate roller lever valve 1.3, because it touches roller lever valve 1.3. Since 1.3 is now activated, it means this one. If this is activated, it activates again left side position of the roller lever valve 1.3. 1.3. So supply will be connected from this port to this port. It will come here. Now this will act as the signal here, will act as pilot signal. It activates right side position of final or main direction control valve. Therefore now compressed air supply, which is nothing but now control air, will go to this side, and it will cause return stroke to start. So when to start extension stroke will be based on activation of roller lever valve 1.4. When to start return stroke will be depending on activation of roller lever valve 1.3. Now please note this important point here in your notebooks. Use this kind of notations in your circuit diagram. Give some names to every control valve. This control valve is named as 1.2. This roller lever valve 1.4. Another roller lever valve 1.3. Main control valve as 1.1. Cylinder, it is not written here, but you write down cylinder as 1. So cylinder 1, main control wall 1.1, roller lever wall 1.3 and 1.4, push button control wall 1.2. Accordingly, here pilot signal also can be given some notation. So pilot signal, which is activating left side position of the control wall, is 114, and pilot signal which is activating right side of the final control wall or main control wall is 1 2. So you can accordingly describe it using this, no, using these notations. And as usual, the ports also should be given proper name. So this is port number 1 coming from compressor, this is 2, this is 3 which is going to exhaust, this is 4 which is coming from the cylinder side, any of the cylinder sides, blank side or rod side, and 5 is again exhaust. So compressor, exhaust, exhaust, cylinder side port, cylinder side port. Similarly here also. So this is also 3, this is 2, this is 1, this is 4, this is 5. Let me know if this is understood. We will go to roller lever wall with idle return. Now only change is idle roller lever wall is used at the end of the extension, so that the return will be due to spring action. It is not activated here. So this will be activated just before. What is the difference? This will be activated just before the end of extension. When it was roller lever wall, it was activated at the end of the extension. This is activated just before end of the extension. So this is idle return roller lever type of wall. Let me do one thing. So please enter your numbers for attendance, and also I will ask you a question. Please give your feedback for that question, and do one thing. Now Google Sheet is there in front of you. Immediately after this lecture, quickly update the Google Sheet. There are 10 students present today. I know who all are absent. Who is not present today? Tejas is absent. Tejas Mani. And Aniket Patil is absent. Right. Tejas Mani and Aniket Patil, right? Today Tejas Mani and Aniket Patil are absent. Okay. So this is the way the idle return type of roller wall works. Rest of the things are same here. Rest of the things are same. Push button wall, roller lever wall, idle roller lever wall with idle return. Then this is main control wall or final control wall. This is cylinder 1. This is start of the extension stroke. This is end of the extension stroke. Here roller lever wall should be positioned along the path of movement of piston and piston rod. Here roller lever wall with idle return should be positioned along the path of movement of piston and piston rod. Let me just quickly ask you a question. Have you understood the application of both the roller liver valves. So this is my question to take a feedback from you. Have you understood the application of both the roller liver valves? Good. Very good. Right. So things are very clear. Now you need to understand how to draw circuit diagrams. We are trying to see that circuit diagram is shown every time if possible, so that things will be better understood. Now here circuit diagrams were shown to you and were explained so as to understand how exactly in the circuit diagram roller lever valves, ideal return roller lever valves are used, or rather the concept of signal air and control air. That is also, I guess, understood to you. Okay. Right. Let me also know from you if you have understood the concept of signal air and control air. So my another question is, can you differentiate between signal air and control air in the circuit diagram? The next question is, can you differentiate between signal air and control air in the circuit diagram? Yes. Okay. If a circuit diagram is there in front of you, then signal air, as we discussed earlier, is up to final control valve. There are number of control valves in the system, but all the control valves are not final control valves. Some of the control valves are actuating or activating final control valves, and final control valve is serving the purpose of making the control air available to either of the sides of the cylinder, let it be full bore side or rod side of the double acting cylinder. So in the circuit diagram you can differentiate between signal air and control air. That is good thing. Now let us see another valves, that is pressure sensing in pneumatic circuits. Now you can observe this diagram carefully. We are going to understand what is pressure sensing and how to do that, which are the valves which are achieving that purpose, serving that purpose. And we will also see a circuit diagram wherein actually we will see this kind of valve which is called as pressure sequence valve. In one of the earlier applications we had seen actually application of pressure sequence valve, but that you will be able to recall better if we will understand what is pressure sequence valve, in which all situations it should be used, how it works, right? So there are last 10 minutes, after which we are going to end today's session. So in next 10 minutes or so, let's see what is meant by pressure sensing in pneumatic circuits. Now, when cylinder piston rod will start its extension stroke, pressure will start building here in this portion. It will start towards the end of extension stroke, but compressed air supply is still on. It is still coming in. So here pressure here in this portion will start building up once piston reaches the extreme position, that is end of the extension stroke, and compressed air continues to flow in here. Right. In one of the earlier applications also, if you recall, we have discussed that at the end of the extension, I think it was the case of embossing operation. There we have seen that at the end of embossing operation, pressure reaches its highest value, or rather pressure increases, right? And that is the point which should be understood, and accordingly you should give a signal so as to start the retraction stroke. When pressure reaches above certain value, next stroke should start. When to start it and stop, that is again a important point. Just because see, just because cylinder rod has completed its extension doesn't mean that retraction stroke should be started. Retraction stroke should be started based on some signals inputs. Sometimes, which we are again going to see, which is again very interesting, sometimes it is also required that there is some time delay between end of the extension and beginning of the retraction. For that, again, we are supposed to use time delay valve, which will take care that there is delay between end of the extension and start of the retraction. For that, time delay valves will be used. So what is pressure sequencing valve? Let us focus on that. Pressure here will start building up once piston reaches the extreme position and compressor continues to flow in. Once a particular set pressure is reached, term set pressure is important because you have to set a pressure with the help of spring. Pressure can be set. You as an engineer who is designing the circuit should know what should be the pressure set. Accordingly, with the help of spring on the top of pressure relief valve, one should set that pressure. If that pressure is reached and if it will start exceeding that particular value, a signal has to be generated to continue next sequence or process. Let it be anything. For example, retraction of the piston and piston rod or any other next successive process. Whether to start that next successive sequence of operations or process depends on identifying or recognizing whether a particular set pressure is reached inside the cylinder or not. Now this can be achieved or this can be done by making use of pressure sequence valve. Pressure sequence valve. Right? Someone is not there. Who is there? Who is that? Who left the meeting? Let me check. Who left the meeting? Akash Ahir is there. Akash Kirtane. Kalyani is there. Kamral. Omkar. Rishikesh. Saurabh. Swapnil. Vishal. Someone has left. Earlier, Aniket was absent. Huh? Aniket was absent.
Yes, sir.
And who else was absent?
Tejas.
Tejas was absent. Now who has left now? Vishal is there. Akash Ahir is there. Abhijit. Abhijit is not there. So give my message to him that I was talking about him. Right? Okay. So this is pressure sequence valve. There are last 4 minutes during which let us discuss pressure sequence valve. So you can see this is a pressure sequence valve which we have used earlier in one of the circuits. So it is very important to understand because you have to decide when to use pressure sequence valve, how to use it, where to locate it, how signal flows, and how your purpose will be served. So pressure sequence valve, which is shown here, which is shown inside this envelope where dotted and dash lines are shown. This is that envelope. This entire envelope is referred as pressure sequence valve, not this or not this. So pressure sequence valve is actually combination of pressure relief valve and 3/2 direction control valve. That is what is called as pressure sequence valve. It is combination of pressure relief valve and 3/2 direction control valve. Right? Now let's see how it works. Pressure relief valve has a spring setting on the top of it, which is variable. Pressure sequence valve is combination of adjustable pressure relief valve. Why it is called as adjustable pressure relief valve? Because pressure relief valve need to have some pressure setting. Now that pressure setting can be adjusted with the help of spring on its top. With the help of the spring, you can adjust the pressure setting. And it also consists of 3x2 direction control valve. Port number 1, 2, 3. 1, 2, 3. Two positions. Pressure relief valve activates when spring pressure is overcome by pressure line coming from pressure gauge. This is the cylinder. The rest of the circuitry is not shown here, but pressure gauge will take input from cylinder. So pressure gauge will understand the real-time pressure in the cylinder. Now, when the pressure is above the set pressure in the pressure relief valve, that pressure will be sensed here. So pressure line from pressure gauge will be coming to the pressure relief valve. The moment pressure in this line is above the pressure set here in the pressure relief valve, this line will move up and it will connect this port to this port. Let's say input port to output port. Therefore, pilot signal will, which was blocked earlier, that pilot signal will move to 3x2 direction control valve, and this pilot signal will activate 3x2 direction control valve. To be specific, it activates its left position. Okay, since left position is activated, signal will pass through this port, it will be connected to this side, and then it will be connected to this line, and then it will go here. Right? And so what will happen? If signal will go to this side, what it means is actually signal is given to the cylinder that retraction stroke or return stroke should be started. Now how the signal is passed? How it is communicated to the cylinder that retraction stroke or return stroke should be started? It is with the help of pressure sequence valve. It is by understanding whether the pressure has reached above the pressure set in the pressure relief valve. If pressure is reached above the pressure relief valve, then there only 3x2 direction control valve position will be shifted, and then retraction stroke should be started. That kind of control signal will be given to double acting cylinder. Now there is only last 1 minute that is remaining. We will have quick feedback on pressure sequence valve next time at the beginning of next session. By that time, just go through it. Meeting will end at any point of time. Let's go through pressure sequence valve. If you have any questions, we will have discussion on it, and I'll have a quick feedback at the beginning of next session. Have a good day. Thank you.
Thank you.
Right. Okay, I think Abhijit had joined back.